Hello, and welcome to Main Street News. Main Street News is here to provide accurate news to help citizens affect change in their local government and beyond. Being nice is overrated. It is time to be real. I mean what I say, and I say what I mean. The time to step up and step in is now. So please come join me, Katie, over on Main Street News to discuss Ohio politics and beyond. I hope to see you there. Hello.
Hello and good evening. My name is Katie and I am with Main Street News tonight. If you're joining us and you're new here, welcome. And if you're coming back, thank you for returning. Tonight we're talking about something regarding my local county. It is Lorain County's MEGA Site in New Russia Township. This site has been discussed a lot in the news lately. And I wanted to come on here and show you all what I have learned about the site and what's coming and what to expect. This is driving me crazy. My mouse isn't matching my. Give me 2 seconds, you guys. I'm going to fix something. Take off this stupid. It always slows my mouse down. It bothers me. Hold on. Let's do original. All right, I'm a little bluer, but I will deal with that because I want you guys to be able to. I hate when the mouth doesn't match the voice. Okay, so we're on here to talk about the Lorain County MEGA Site. What is it going to be? Is the question. And I put out an article yesterday explaining that I believe that the Lorain County MEGA Site is going to be a Lorain County Community College Advanced Technology Campus. And I know a lot of people came on and said that I'm wrong and I don't know what I'm talking about. And yeah, okay. I really don't care about those comments just because me personally, I'm not going to talk about something that I haven't, researched thoroughly. At least come up with some evidence to back up my claim. And it's one thing that they've been working on for the last, 3 years that actually makes a lot of sense. And this is what it would be. Now, I did do a records request and I'm going to share that with you. And what I did is for my records request, I made a timeline. I didn't get a lot of records. It took me I still haven't got a copy of a signed NDA from the microchip contract. That was going to be the first one. I do have a blanket NDA that I got from my records request that I'm going to show you from Jobs Ohio, and I'll talk about later why I have an issue with that. But for now, what is the proposal here? Give me 2 seconds. I got to share my screen with you. Make sure my audio stays because I always lose my audio when I do this. Now I'm going to go off to the side here. Yeah, I'm going to do a little off to the side because here we go. So I want you guys to be able to read my timeline. So this is what I did. I made a timeline. So instead of going through every single email, the good ones, I'll show some good ones I'll show you. But here we go. Starting in February of 2024, there's support for Lorain County MEGA Site indication of interest document for the All Ohio Future Fund potential 1,000-acre contiguous site. That's not just the county's acre. That is also the property surrounding it. It's Sarah's Farms, I believe, that owns a lot of it. And Sarah's Farms is not a farm. Sarah's Farms is I believe, land acquisition company is the best way I can describe it. So in that document, though, it said Lorain County MEGA Site is an unparalleled opportunity to attract and secure advanced manufacturing projects, including semiconductor fabs, which increasingly seek large development, ready locations with comprehensive utility support. Now pay attention to semiconductor fabs. There's an email to Jeff Riddell, Commissioner Jeff Riddell, his assistant, Grace Galucci, Rob Duncan. Bonawanka is preparing a letter for the MEGA Site on March 1st, 2024. There's another email about the sewer district on August 8th, 2024. New version of the regional sewer district reference slide notes. I have to request a full PowerPoint for that. It's one of my to-do lists. May 7th, 2025, there's an email between Renee Liggins, Lorain County, and other counties with projects worried the Ohio legislature was going to pull the $750 million Ohio Future Fund, so they wanted support for that. Here's another email, May 8th, between Jeff Riddell, Jeff Armbruster, Dave Greenspan, time-sensitive urgent, All Ohio Future Fund at risk, So there's another one. I know Marty Gallagher said publicly he did not sign an NDA, but I do want to let you guys know, I don't know if he signed this because I don't have a copy of it. However, he was sent a blanket NDA. Now, I'm not sure if it was for this project, but I don't know why they would send it to me when my records didn't request it if it wasn't for this project in some way. I don't know. I would like, an answer for that. Tiffany McLeland is Marty Gallagher. Brad Mullins, please find the attached template NDA used by Jobs Ohio. This should be a good working draft to adapt our uses. I can work to adjust for Lorain County, the port, the company. Feel free to provide any red line changes you see incorporated outside the obvious need to update the parties. So then we go to July 21st, 2025. That's actually my birthday. The article announced the award winning of $67 million from the Ohio Future Funds. There's a bunch of emails about that. Then there was an article, Cleveland Business, discussing the MEGA Site. Manning says on there that the site has the water there, and she's not referring to the sewer. So maybe underground groundwater, as I'm thinking. I have questions. Why does Tineo talk about the vibration? But if it's going to be a microelectronical, if it's going to be a MEMS advanced, because you don't want vibration for that. It said it's developed in 3 to 5 years is the plan. DeWine says has been pushing shovel-ready sites, invested $750 million in 2024 through the Future Fund. So that was that email. So then, and this is why I really think it's going to be a Lorain Advanced Tech Site, and I'll show you the document. October 27, 2025, there's an email from one Lorain County to the Commissioners, Armbruster and Greenspan. It's from Christine Nelson about the MEGA Site communications plan. In October, if we do the math, I said about 6 months you guys have been advocating against this. That would line up for when you guys started advocating against this. They put something together that they were going to then put towards the media. I don't know why they chose not to, but, they didn't drop the project in the last 6 months. And they're not going to create something like this to then, you know what I mean? Like, it doesn't make sense. But it's the documents, Lorain Advanced Tech Campus. It's a unified message, okay? And I want to pull up a couple of those documents right here just to show you guys. I know I'm going through this quickly, but it's pretty clear. So I'm going to go back before I go forward. We're going to start in 2023. This is one of the documents that was sent to me. Okay, and this is from 2023. And August, I believe, just based on when John Husted, former Lieutenant Governor John Husted, um, now Senator, kind of congressional senator, John Husted, he was appointed by DeWine in 2024. There's this PowerPoint here, and this PowerPoint, it says, Lorain County welcomes Lieutenant Governor John Husted, state of Ohio. Okay, Jeff Riddell was there. I believe the Mannings were there. I think Dick Stein at the time was there. I don't know who else, but I guarantee other people. Team Neo, okay. And then here is what they wanted. The site. It says a premiere. So the person that yesterday put that map up, they put some map up the saying like, oh, look at these buildings. It's not what they're building because it was like this instead of the way my map is. Look at this. It's the same map that you had for LCC. So the premier opportunity for large-scale advanced manufacturing industrial projects, Northeast Ohio. Now, this is just the campus that they're proposing. Here's the first one. If they annex the airport, okay, if they decided to, there's going to be a couple drafts, okay, because here's the airport. Here's all the land that they're saying is the potential. You see how these little ones are carved out? That's private land, okay. So here is the option 2, which I think is it's gonna be, because option 1 was like over, I don't know if you guys can see my mouse or not, but over here where it says future business park, advanced manufacturing site. So here's the campus that they want to do, and you guys have seen this in my article, this picture, and then off to the left, I don't know if it would be your guys' left, there'd be an advanced manufacturing site, 600 acres, then a future business park, another 300 acres. So what they're looking on doing is they're looking on, doing this campus, but around the campus, they're going to put companies that manufacture those chips, and then a business park, like another park to support that manufacturing side of it, which is, I think, quite interesting. And it makes complete sense because, no offense, you would manufacture these here, and then if you want to ship them, the airport's right there. You don't have to drive them far. You don't have to, and I don't know. I think there's some kind of like special way to transport these. I'm not really quite sure. Now, here was the second idea, if they were to, because they were thinking about annexing the airport, and if they were going to annex the airport, this would have been what they're going to do. Okay. And then they talk about the regional sewer district, Jeff Armbruster, and this is in 2023. Okay, this is 3 years ago. Marcia Ballinger, she's still the president of the Lorain County Community College. In 2012, Site Selector magazine had workforce skills ranges the 7th most important location criteria. 2021, 2022, it's number 1. And then here are all the people partnering: Ohio Manufacturers Association, Ohio TechNet, Intel, because they even say in an article it's like an Intel semiconductor thing. And then its unique capabilities, it's a smart industrial automation and robotics, and then the MEMS and microelectronic manufacturing. They got $2 million for manufacturing job training from the Department of Energy. That is just going to increase. Okay. And then TechCred, Earthquaker Devices, Allied Electric, I forget what this company is, but I have it written down. Ohio Individual Micro-Credential, blah, 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 blah. But what does it say on this 2023? We are ready. Best mega site location in Ohio for Industry 4.0 end user, expanding utility infrastructure, your sewer line, premier talent development, strong state, regional, and local collaborative partnerships. Questions, comments? Okay, and he visited for this. Here's some pictures. Now, even before this, though, okay, before this, in 2022, Senator Husted, does it pop this open? Probably not gonna be able to see it. Visited the campus, okay? I hate this website. It's like the most obnoxious one. So in this, he discusses like the new jobs and the technology, blah blah blah. Okay, you guys can go through that in your own time because I'm done with the chronicles. I'm gonna pop up a thousand ads at the same time. And then he visited in 2022 as well on York College Memdental partnership, where they're actually doing a new advanced technology campus. Around this time was when that microchip project idea was brought up. Okay. Yeah. And then in this article, actually, I'm gonna bring up this article because it just makes more sense. Is I actually printed it, July. Where are you? What's the date on it? Because I do everything by date. 3/3. Give me 1 second. 3/3. Did I not save it? No, I didn't save it, did I? I had to have saved it. Hold on. I probably just didn't transfer it. Shh. 2 seconds. Oh, Joe. I didn't, did I? Dang it. I thought I printed it. Anyways, in this article, here's the link. It's not going to pop up for me because it likes to block. I pulled up the Chronicle too many times. I'm not paying for it because it's the Chronicle. But they talk about when you pull it up, if it loads. Come on, guy. It even talks about, yeah, here we go. Ohio, it's little, because you can't get into it. It says Ohio community colleges will have a slate of new courses and career pathways draw from supporting Intel new semiconductor manufacturing campus. And they're talking about his visit to Lorain County manufacturing campus, a new Intel new semiconductor manufacturing campus. There you go. And then when you go to the county, this is why I wanted to. Then when you go to the county in October of 2025, when you guys were all getting upset about this, saying it was a data center, even though they were saying it wasn't, they wanted to do some messaging. Now, why they didn't put out the messaging, I don't know. Couldn't tell you. But this came in my records request. So it says Lorain Advanced Technology Campus, Unified Messaging, and this is October of 2025. So this was less than 6 months ago. Well, 6 months ago. And it says jobs for the future. Okay. This is their talking points. Creating high quality future facing careers that attract and retain top talent, roles in engineering, research, data science, operations, technology support. I'm not reading through all of these, but I will put it up here for a minute. So if you guys want to, they're going to create white collar careers. The project gives local students professionals reasons to stay in Lorain County. Partnerships with local schools, community colleges, and universities will build direct pipelines into these advanced technology careers. Every professional role created will generate opportunities in education, housing, and healthcare, economic growth, and regional competitiveness. Okay. And here's your talking points. The advanced campus positions Lorain County is a key player in the global technology, economy, attracting respected partner in fields like AI, data infrastructure, and advanced computing. This once in a generation opportunity to transition from a legacy industrial base to a clean, innovative driven economic model. Each phase of the campus will attract complementary businesses. Like I said, like that map, it's going to build off of whatever. Research, logistics, design, and professional services, creating a multiplier effect for the region. The project broadens the township's tax base and reduces long-term reliance on finite revenue sources such as landfill profit sharing. The communities that embrace innovation today will define the state's economic success tomorrow. This project ensures Lorain County leads in that story. Infrastructure and community investment. Infrastructure investments, road, utilities, water, broadband, transportation will be built to the state-of-the-art standards, improving reliability and safety for all residents. These upgrades won't just serve the campus, they'll strengthen the entire township and open doors for additional community growth and services. This project will unlock state and federal infrastructure grants, wouldn't otherwise be available to a small community like New Russia, like New Russia, like New Russia, like New Russia. This is October 2025. Long-term planning ensures upgrades done responsible, modernization infrastructure, and then revenue, public services, stable long-term financial sustainability that strengthens community services and quality of life. The Advanced Technology Campus will create new recurring tax revenues that directly support local schools, safety forces, and essential township services. The new revenue from that campus will help fund parks, roads, public services. The environmental stewardship and responsible development, blase, blase, blase. It's going to be a green infrastructure. It will not be a traditional industrial site, so it's not going to, look like smokestacks, heavy machinery, around-the-clock traffic. World-class technology partners will implement sustainability best practices, setting a new benchmark for responsible development in the region. The plan includes landscape buffers, da 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 da. So then, this is a smart, clean, forward-looking development growth that protects what residents love the most about New Russia. Partnerships, progress, and pride. Local, county, and state leaders are aligned to support this project. Represents a shared vision for sustainable growth. Advanced Technology Campus has the potential to attract one of the world's most respected technology partners, putting Lorain County on a global innovation map. This is about building something lasting, a place where Ohio Town can thrive, next generation dream big, communities that invest in the future become models to follow. New Russia has a chance to lead by example. Years from now, this decision will be remembered as a turning point, a bold movement when local leaders said yes to progress, innovation, and opportunity. And then what they did is they drafted you a letter, subject, dear resident, blah, 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 blah. And then all those talking points were implemented into it. It says LCC offers programs in advanced manufacturing, automation, robotics, cybersecurity, and data analytics, creating a direct pipeline from education to employment. This partnership ensures local talent is prepared for the careers of tomorrow, and the companies investing in Lorain County have access to a skilled workforce. In keeping with the desires of the community, the environmental preservation stewardship is a cornerstone of this project. The campus will exceed all environmental standards, incorporating energy efficient design, green infrastructure, and landscape buffers. So then they go on the once in generation opportunity. Now, this is in October of 2025. And then I'm going to go back a year and just to show you real quick. And in 2024, they met, John Houston was out here again, and he met with, where's the Facebook thing? Hold on. Facebook, here we go. In August of 24, a year before that, he was meeting with all of the entities working on the sewer and New Russia project. The only the people that weren't really invited was New Russia. So here is this post. If it loads. Come on. You can do it. I gotta get a new computer. Okay. So August 12, 24, big thank you, Ohio Lieutenant Governor John Houston, for meeting Lorain County's community and economic development leaders this past week. All of these people, see all these people, who are there. Not tagged them. Hold on. Say Oberlin, Avon Lake must be back there. But anyways, during his visit, Lieutenant Governor spotlighted Ohio's impressive national economic progress, hosted Lorain County Community College. This gathering is part of a quarterly series organized by Lorain County Community Development Director Rob Duncan, who was in that thingamajigger, focusing for the Ohio Jobs NDA, focusing on the latest updates and initiatives. Now, City of Oberlin tagged 10 others. Who are the 10 others? The Ohio Governor's Office for Workforce Transformation, Workforce Advanced Technology Campus, Ohio Means Jobs, City of Lorain, Lorain County Stormwater Management, Lorain County Ohio Government, Lorain County Chamber of Commerce, City of Elyria, Team Neo, City of Avon Lake, Lorain County. All right, who's in charge of this project? Let's go back. Hold on. Where are my partners? Here we go. LC affiliates with Advanced Tech Campus. How many? LCC. Oh no, wrong one. Who's working on this project? It is, sorry, Team Neo Aligning Opportunities. Here's all their stuff here. Spacebound, Thogus, Cleveland Clinic, One Lorain County, Lorain Port Finance Authority. So, before I get to what happens next, what are MEMS? Okay, no, everybody always is like, what the heck are you guys talking about? Remove this real quick. What are MEMS? I'm gonna play you a little video. Give me 2 seconds. I'll press play. Hold on, it's down.
As we get into nanotechnologies?
Yeah, nanotechnology, we call this NEMS, nano electromechanical systems. So they're actually building resonators that are almost hair-like. In your ear, you actually have these hair filaments that sense sound. We're duplicating that. We're making very tiny piezoelectric fiber-like structures. Those can be used for audio applications, radio frequency applications. And then, of course, you can leverage everything that leading edge node semiconductors can do. You can two-dimensionally pattern things in the nano geometries. And that is slowly being adopted by the MEMS community. Typically, MEMS devices right now are in the, I would say, 100 nanometer and bigger line widths. So it's kind of a trailing edge technology. We like to think of it as a more than more technology. So it's not following Moore's law, but it's doing some strange things at these larger geometry levels that can't be done with traditional semiconductor wafer fabrication. And whether that's three-dimensional structures, alternate materials. I recently did a project for a number of years where I was 3D printing stainless steel wafers or titanium wafers for very harsh environments. So you're building up these resonators out of titanium using three-dimensional printing, laser printing. And you're instead of using silicon, because silicon's a fragile material, it's not corrosion resistant per se. And so the MEMS technology allows you to look at a whole broad spectrum of materials to select from, and then interleave that in with traditional semiconductor layers and lithography techniques.
Wow, that is exciting. Now, as you know, traditional electronics has gone up to almost the angstrom level with 3 nanometers, 2 nanometers. Does that mean that MEMS and NEMS have a long way to go and they can continue to shrink and continue to follow something like Moore's law going forward?
I think they will. There's really no limiting factor other than it's a more expensive. Obviously, the 300 millimeter, 2 nanometer wafers are extremely expensive. You know, only Apple can afford to buy them. MEMS technology is so widely dispersed, and it's more of mature node technology. But like any mature node technology, as the capital costs go down for these tools, they'll be adopted by a wider and wider spectrum of applications. And
So it's a little overview at the end of this video. I'm going to provide you guys with, let me share this. I'm going to provide you guys with a 10-minute and 12-minute video that actually goes into like the details of what is made with them. But it's a tiny microchip, pretty much. Tiny, very small, very small. So, you know, you don't have all of these partners either, okay, on a project, and then just say, you know, we're not gonna do that. You know what I mean? Like, you have, you know, here's the affiliates with this project. They're still getting money, by the way, too, from Governor, now not Governor, Houston, about that. Now, this is going to happen is since the zoning didn't pass for New Russia Township, what they're going to do, the owners are going to sue, okay? In Ohio, property owners can sue when the zoning change is denied. If they prove the denial was unconstitutional, arbitrary, unreasonable, often claim it constitutes a regulatory taking by rendering a land unusable. After exhausting administrative appeals, developers, owners may file civil lawsuits, contest decisions that destroy property value, as seen in a recent Ohio litigation involving rezoning reversal. There's a case in Clark County. It literally took them 2 months. They were ready to sell because the court upheld that you can't. They proved that there was going to be an economic loss for them for not being able to, sell this land or whatever, and the court sided with them. Now you have two other. After that, it's annexation. In Ohio, it's legal process in which an unincorporated land from a township is transferred to the adjacent city or village, typical for municipal services like water or sewer. It requires a petition by the landowners and approval of the county commissioners and municipality. The municipality isn't going to say no. They want those taxes, okay? And the county commissioners will eventually approve that. The township will then lose tax revenue from that area. Or if the township wants to actually benefit from this land being developed, that's going to be developed, you can do a joint economic development district. This is a partnership authorized by the ORC, allowing townships and municipalities to cooperatively develop commercial and industrial land, share income tax revenue, and foster economic growth without annexation, impose income tax on businesses and employees with the area to fund infrastructure and services that they can't do now as a township. So, that's where you're at. It's not that, and people are like, oh, you're for it. I'm not for this or against this, per se. I want to know more about this, but this is what's happening. There's no stopping it, which is why I haven't gone to those meetings and why I haven't, participated in advocating against it, because this is done. They've been working on this for years. You have many businesses, invested, you have the schools invested, and you wonder why your representatives aren't against this. It's because they promote this campus, one of a kind campus. LCC is the first to offer the bachelor's degree in MEMS, micro electrical manufacturing technology. So it was just done. Before it even started. Now, this is my issue with this entire project, is this right here, which is an NDA, okay, that was sent to Marty Gallagher in 2025. I don't know if he signed it, but this is what was sent. And this is from Jobs Ohio. Now, Jobs Ohio is supposed to be a charity organization that works on, projects and stuff. But this is what I have a problem with. This is what I've always had a problem with, is no elected official should be signing NDAs in regards to public lands, public companies coming in to do business with the public. Now, if they're signing this NDA to not discuss what is being sold on the private land that the county doesn't own, that is being, I don't know. And then I also want to know what the hell the Port Authority has to do with Jobs Ohio and this NDA and the Port Authority, which is really weird because that's too many public entities. And I don't think you should ever, as a public official, sign an NDA. But at the same time, as a public official, if you sign an NDA and then you talk about something that's public business in the public atmosphere, they can't sue you because you signed an NDA. That's public business. You know what I mean? So it's ridiculous. And my biggest issue here isn't so much with the local officials, it's with Jobs Ohio. Because Jobs Ohio is pretty much a charity to launder public funds, okay, through and not have to tell, and they work with different companies, tech companies, data center companies, whatever, as the middleman, so they don't have to show the public, because they're the private business that's getting public funding, that was set up by our government, that they don't have to show us where the money is going. And I have a really big issue with Jobs Ohio. I have a really big issue with even NEO and stuff working with that. Like, if there's business, if they're receiving our tax dollars to invest in companies coming to whatever places in the county, that should be public record. But they do it through this charity, Jobs Ohio, so they can launder that money through, I don't mean launder, but they can give that money and then use that money, public money, without any transparency to the public itself. Okay. And that's my issue. And here's a document. What I'm going to do is I'm going to put all these documents for you guys in a Google folder, and then you guys can, go through them. I'll do that with the emails that I have as well, so you guys can see the emails that I have. But yeah, this is going to be Advanced Technology Campus, absolutely. And before I do my next recording, my last 15 minutes is going to be a video for you all. Let me get out of this stuff so I don't slow it down. Oh, and I wanted to show this because Gallagher said he never signed one, but he was sent one. I want to show you all this. So I know he said that during a public meeting. He's like, oh, I never signed an NDA, but you were sent one by the Lorain Port Authority. Okay. So I wonder why they would send you one if you didn't sign one. That's my other question. And then I want to bring, I'm going to put this video up, and while I get ready for my recording, so I'm doing a late night recording, I'll stream in the morning. You guys can watch this. Here we go. Give me a second. Big one. Yeah, right here. It goes over more about MEMS technology in detail, and you guys can watch this when this is over. The stream will be over. Give me 2 seconds. I gotta pause this before it. So before I do that, you guys, hold on 1 second. So yeah, it's pretty easy. I'm not overcomplicating this for anybody. Pretty easy to see that the project here is going to be an Advanced Technology Campus, or LLC. I'm not against it. What I am against is all the secrecy behind it. I don't like that, especially when it's public land that you're selling. It's our land, especially when, this is way better than a data center. I've asked people, like, why wouldn't you just say it? Why wouldn't you just say it out loud? Be proud. This is what, even Lieutenant Governor Houston's been working on. He's been working on this data center stuff. Like, but it hasn't been a secret. Okay. Like I said, it just hasn't been. Here's from 2024. Here's from 2022. Like I said, 4 years. That's 4 years ago. Okay. Walking through campus. It's been out there. We just all haven't, seen it. But it's been there. It's been, this was even from 2023, this image right here. We just didn't put it together, which is fine. I'm not, but this is why they're not going to rescind this All Ohio Future Fund. And this is why, both representatives, purple people leaders from the right and from, I heard somebody, Joe Miller or something, said you guys are confused on this project because they know what this project is. They've been working on it. But stay focused, Lorain County. I'm going to leave you off with a video, and you all have a good night. And thank you for joining. I appreciate it.
Imagine a tiny speaker as big as a microchip, smaller than a penny and made entirely out of silicon. A speaker. That's the miracle of MEMS. MEMS, or microelectromechanical systems, are microsystems with both electric and mechanical functions. Built using the same advanced techniques that make today's integrated circuits, MEMS are everywhere around us. The technology is miraculous, but the industry has long struggled with several significant economic issues. In this video, we're going to look at the big problems with making small mechanical systems. But first, let's talk about the Asianometry Patreon. If you like what this channel does, you can support the work by joining the Early Access tier. Plenty of room at the bottom. In it, he dreamed of making things really, really small. In 1959, Richard Feynman gave a lecture at Caltech called There's Plenty of Room at the Bottom. In it, he talked about directly manipulating atoms one by one to create useful tools. He offered a prize of $1,000 for the construction of a tiny motor capable of fitting in a cube 0.4 millimeters on each side. The reward was claimed less than a year later by a Caltech engineer. The engineer, however, had made this little motor using conventional tools, which met the letter of the challenge, but not its spirit. It was not until 1967 when Harvey Nathanson at Westinghouse used pre-modern micromachining techniques to develop a new type of transistor, the resonant gate transistor. About 1 millimeter long and made of gold, the special thing about this transistor was that it can move. Using electricity, researchers can control the distance between the gate and the electrode. Because it only responded to a narrow range of input signals, it was useful as a frequency filter, the first real MEMS product. It would not be until 1979, however, when MEMS hit the big time. Hewlett-Packard used silicon micromachining techniques to develop a printer inkjet nozzle to enable thermal inkjet technology. Such nozzles would probably be the technology's single most successful application up until then. Inkjet technology works by first rapidly heating up ink to something like 100 degrees Celsius. This creates tiny bubbles, which pushes out the ink through a micromachined nozzle onto the paper. When the bubbles collapse, it creates a vacuum that sucks in more ink. The nozzles themselves aren't mechanical. They don't move. But MEMS technology helped create them, and their tiny size allowed HP to put a whole bunch of them together in order to increase printer resolution. Then, in the 1990s, the MEMS industry discovered another major commercial use with sensors for acceleration, pressure, and direction. Such sensors are useful in the industrial, medical, and electronics fields. First is the automotive airbag sensor. I spoke about this in my video about automotive semiconductors, but the original airbag sensor was a mechanical device, essentially balls in a tube. These were large, heavy, complex, and expensive, costing hundreds of dollars. In 1991, Analog Devices created the first commercial acceleration MEMS sensor, less than 1 square centimeter large. It looks really cool with a number of capacitive sense fingers, about 60 microns deep. The fingers are attached to a mass which moves when acceleration happens. The touching fingers change their capacitive value, which then is sensed by the chip and relayed to the relevant ECU. Analog Devices put this accelerometer and its accompanying electronics onto a single silicon chip, the ADXL50. 50 because it was able to sense sudden accelerations of up to 50 Gs. A complete monolithic acceleration monitoring system that is smaller, more reliable, and costs far less to make, $5 as opposed to the old system's $20 to $100 cost. These accelerometer sensors contributed to the widespread adoption of airbags in cars. Your standard car has since incorporated dozens of MEMS-based sensor devices inside your anti-lock brakes, active suspension, navigation control, rollover detection, and so on. Over 60 million MEMS-based airbag sensors alone have been made and sold. The pressure sensor would be the next big application of MEMS technology. They are used to monitor blood pressure in hospitals, connecting to a patient's intravenous line. Early external blood pressure sensors cost over $600 and had to be sterilized and recalibrated for each reuse. The MEMS version cost a fraction of that, just $10, the majority of the cost going to the packaging, which made it disposable and far easier to use in the medical field. Mechanically, they are quite simple. Using MEMS technology, you craft silicon into a thin membrane, which serves as a diaphragm. Then you take 4 small stress-sensitive polysilicon resistors, or piezo resistors, and place them along the diaphragm's edges. The diaphragm is then suspended over a vacuum cavity to form an absolute pressure sensor. When pressure occurs, it changes the silicon band structure and changes the resistivity of the crystal. This is sensed, and the signals are delivered to the relevant parties. Today, the medical MEMS-based sensor industry is worth over $6 billion, and blood pressure sensors make up the single largest piece of that. Manufacturers eventually built on the initial pressure sensor and accelerometer designs to create a variety of versatile low-power sensors. And these inertial MEMS-based sensors, as they are called, are inside all of today's hottest consumer electronics. Take the Nintendo Switch. Inside the main console and controllers are ultra-low-power inertial sensors with gyroscope and accelerometer capabilities, the ST Microelectronics SH627. MEMS micromachining technologies are also used in other consumer electronics products like visual displays, optical switches, and more. The latter is pretty interesting, where micromirrors are used to redirect light from one optical fiber to another fiber. The idea behind most commercial MEMS production workflows is to use high-volume IC techniques, like for instance photolithography and etching, to add or remove layers on a 2D substrate until you produce a 3D shape. However, there is no one-size-fits-all methodology for the industry. Thus, companies have tried other approaches to more economically produce and machine MEMS. For instance, electrochemical micromachining. First introduced as a manufacturing technology for low-end PC boards, ECM can create a MEMS by locally and selectively etching metals with an electrode tip. Other micromachining methods include laser beam machining, electrode discharge machining, and LIGA, which stands for something I cannot pronounce. Better machining costs are necessary because it sets a high hurdle for payback and profit. However, large-scale MEMS fabrication is just one part of the ecosystem. Others significantly contribute to cost and production issues, the design and the back-end steps. So MEMS and integrated circuits have a whole lot in common, but it would be a mistake to link them too closely together. Fundamentally, there are some very clear differences between the two. The first is in the design. Designing MEMS is pretty interesting and specialized. You can't just miniaturize things and expect it to work the same way. For instance, the forces of friction are much stronger than inertia here. On one hand, tiny flow spaces are much more prone to fluid blockages. These have to be ameliorated. On the other, certain biochips can use electric fields to pump reactant around the chip. This is only possible with electro-osmotic effects that exist at a micrometer scale. Beyond that, there are fundamental philosophical differences between semiconductor and mechanical design. VLSI revolutionized semiconductor design with a modular approach to large systems design. In VLSI, you can build up entire systems and chips by combining parts from generic modules and standardized cell libraries. The library is designed independently from the product, most often in conjunction with the production process, like TSMC and their nodes. This helps make sure the final product yields. The mechanical design world does not have anything like this, with the exception of standardized bolts, fasteners, pipe fittings, and paint. Those are made by subcontractors uninvolved with the final process. Instead, mechanical components have to accommodate weight, space, and energy restrictions tailored to the specific product. And VLSI objects only have to do one thing. They process signals, usually logic. Mechanical objects, on the other hand, have to contain liquids, rotate, slide, or support loads, often all at once. And this makes mechanical design, MEMS included, extremely custom. With all that being said, there are companies making CAD and design automation software suites for the MEMS industry. Examples include Coventerware and IntelliCAD. These have contributed a great deal to helping MEMS designers better understand the microstructure design and its electromechanical behaviors. Testing and packaging are described as the back end of the semiconductor production process, where you take the finished die and turn it into a chip for inserting into the final product. Unheralded, they are nonetheless vital. Looking at typical pricing, the majority of the price for a MEMS-based sensor comes from the packaging, 75 to 80% of the final cost, which is a big reversal from the situation for integrated chips. For instance, let us look at a pressure sensor for something like the heating and ventilation market, or HVAC. An HVAC pressure sensor is typically priced at about $20 to $30. The majority of that comes from the packaging rather than the actual die. A raw working die from a foundry without its packaging, and unusable by the way, costs less than 50 cents a piece. The issue is fundamental and philosophical. An IC is a system in of itself. Thus, packaging serves a secondary support role, protecting it and interfacing it with the outside world. So most of the time, you put it into a plastic or ceramic case. MEMS, on the other hand, has to intimately interact with the outside world. You cannot throw a MEMS pressure sensor into a hard plastic case. How is it going to sense the pressure? The packaging for each MEMS die has to be remade for its particular circumstances. A pressure sensor MEMS needs different packaging than a micromirror array. A microfluidic MEMS different from an electrostatic actuator, so on. This adds substantial cost and engineering cost to the work. As I mentioned, Analog Devices was one of the first major semiconductor companies to invest in the MEMS world with their miniaturized accelerometer. The company started researching the space in the 1980s, specifically targeting the airbag sensor industry. They built their own in-house manufacturing facility to scale up production. But it took 9 years for that facility to come into the black. The problem was pricing. From the very start, Analog Devices marketed their product as having a significant price advantage over the competition. So when Analog signed its first automotive sensor deal with Siemens for its MEMS products, they had to build in automatic price declines over the next 6 years from $11 per unit to $6. Analog did this because they thought they could get much more efficient on production. Much like for the IC industry, yield is the single biggest influencing factor for product cost. A 10% yield means that 9 out of 10 MEMS products are not usable. Doubling the yield means halving the cost, but this is not exactly easy to achieve, which leads to overly optimistic projections of what's possible and market prices that do not reflect the actual investment put into the whole process: development, production, packaging, and testing. Relentless market price erosion, as high as 3 to 5% each quarter, eats away at margins and disincentivizes investment into other potentially exciting possibilities for the MEMS industry. For instance, micropropulsion technologies for small cube satellites, or MEMS-based LiDAR mirrors for autonomous cars, or IoT sensors, whatever those might end up being, and so on. MEMS has been called the second silicon revolution, and it is still magic. You are talking about microscopic moving parts that can do the same things as much larger things. They are smaller, cheaper, and work better. That's magical. But the industry has partially been the victim of its own success. Its creativity and diversity make it harder to come towards a widespread standard. And MEMS has nothing like a Semitech or a DARPA working within the industry to map a way forward. I reckon that for the industry to realize its full technical and commercial potential, that the various players, the 50-some designers, foundries, vendors, and end users all about, need to start working together more closely to make standards and find solutions to the underinvested issues that plague it. All right, everyone, that's it for tonight. Thanks for watching. Subscribe to the channel, sign up for the newsletter, and I'll see you guys next time. Imagine a tiny speaker.
Thank you for joining me, and you all have a good night, and I hope you learned something. If you have any questions or concerns, feel free to email me at katebuyer21 me.com. And you all have a good night.
Thank you for joining me today on Mean Street. I hope you enjoyed the show. I would greatly appreciate it if you would consider supporting our work and supporting my effort. You can support directly underneath at the Spotify donations, or you can directly give a donation at paypal.me/meanstreetohio. Any donation received will help me continue to provide news to you and everyone else across Ohio and beyond. I love what I do, and I just hope to continue to do it. Thank you so much, and you have a wonderful day. Thank you for joining me today on Mean Street.